So, good afternoon, everyone. What was the topic that we have discussed in previous class? We have discussed regarding moving charges and magnetism. In moving charges and magnetism, we have finished the concepts of Biot-Savart law, Ampere's law. Further, we have seen that a device which is used for accelerating the positively charged particle that is called as cyclotron. Further, we have obtained an expression for magnetic dipole moment of a revolving electron. Now, I will start today's class with one small concept which we have missed in electric potential and capacitance. There is nothing but the amount of energy stored in the capacitor. After discussing that concept, we'll move on to the next SAQ chapter, that is atoms. So first of all, I will discuss a small concept based on electric potential and capacitance. There is one small concept of electric potential and capacitance. Electric potential and capacitance. In this, we have already discussed the concept regarding electric potential and capacitor. From that, we are going to discuss the amount of energy stored in the capacitor. Let us consider a capacitor. Here, I am having a capacitor. Now, initially, this capacitor is having no charge. Initially, is there any charge inside the capacitor? Zero charge. Next, what I did, I have applied some potential to this capacitor. I have connected a battery to this capacitor of potential V. This is positive terminal of the battery. This is negative terminal of the battery. What will happen? Now the capacitor starts to charge. Let us assume at some final time, this is initial, this is final. The charge inside the capacitor is how much? Q. Initially, I haven't connected the capacitor to any battery. Initial charge inside the capacitor was 0. Once I have started to connect this capacitor to a battery of potential V, what has happened? The capacitor has started to charge, and how much its charge has become? Its charge has become Q. Now, we know that capacitor is having a capacitance C, and what is the formula for capacitance? It is given as what? C is equals to Q divided by V. From this, I can write potential V is equals to Q divided by C. From the formula of capacitance of a capacitor, I can write down the formula for potential as what? V is equals to Q by C. Now, the work done in charging the capacitor is given as integral V into dq. What does this W represent? W represents the work done in charging a capacitor from 0 to Q. So that is given as W is equals to initial charge was 0, final charge is how much? Q. And what is the value of V here? The value of V is Q divided by C into dq. So here C is constant, whereas Q is variable. So what this will become? This will become 1 by C integration 0 to Q, Q into dq. And what is the formula? Integration x power n dx. What is the formula for integration x power n dx? It will become x power n plus 1 divided by n plus 1. Similarly, what will be the formula for Q into dq? What is the power of Q? It is 1. So this will become what? Q power 1 plus 1 divided by 1 plus 1. It will become what? Q square divided by 2. So if I substitute this value, what this will become? This will become 1 by C into Q square by 2. And from where to where it is changing? 0 to Q. 0 to Q. If I substitute this value, whatever work we are doing, that will be stored in the form of energy. And this will be given as Q square divided by 2C. So this was a very small concept left out in electric potential and capacitor, not that much important. But once he has asked this question for 4 marks, so that is the reason I thought that I should discuss this question. What is the question? He'll be asking you to determine the amount of energy stored in a capacitor. Initially, we have considered a capacitor whose initial charge was how much? Its initial charge is 0. Once I have attached a battery of potential V, the capacitor has started to charge till which amount? Till it reached a value of Q. So I know that potential is given as V is equals to Q by C, and the work done is given as total work done in charging the capacitor from 0 to Q is given as W is equals to integral V into dq. Further is nothing, basic mathematics. I hope you understood this. Let us move on to the next chapter, that is atoms. Again, very important chapter for 4 marks answers or short answer type questions. What is the next chapter? The chapter which we are going to discuss today is atoms. See here, I will start with basics. After that, we'll move on to the actual SAQs from this chapter. See here. First, we know that regarding the structure of atom, we have one model that is called as Thomson's model. Thomson's model. I hope everyone might have studied this question in your lower classes. What he said? He said that atom is a positively charged sphere. What is that? He said that atom is what? Positively charged sphere. He said that atom is a positively charged sphere. Here, positive charge is uniformly distributed. Further, he said that radius of atom is 10 power minus 10 meter. This was the information given by whom? Thomson. He said that atom is a positively charged sphere and this positive charge is uniformly distributed throughout the sphere. Further, what he said? He said that negative electrons are embedded inside this atom. Negative electrons are embedded inside this positively charged sphere. Negative electrons are embedded inside this positively charged sphere such that total negative charge is equals to total positive charge. Total negative charge is equals to total what? Positive charge. This was the information given by whom? Thomson. Further, he said that if total negative charge is equals to total positive charge, we can say that atom is neutral. Atom is neutral. So what was the theory given by Thomson? He said that atom is nothing but a positively charged sphere with a positive charge is uniformly distributed throughout the sphere. Next, he said that electrons are embedded inside this positively charged sphere. And further, what he said? He said that total negative charge is equals to total positive charge. And further, from this, we can say that atom is neutral. After this, Rutherford was performing some alpha scattering experiment. See here, this is the failure of this Thomson's model. What Rutherford was doing? Rutherford was performing alpha scattering experiment. Alpha scattering experiment. As Thomson said that the entire sphere is positively charged and alpha particle is also positively charged. When Rutherford was performing this alpha scattering experiment, this one particular experiment, so see what I was telling. So Thomson said that atom is a positively charged sphere in which positive charge is uniformly distributed. And Rutherford was performing an experiment with alpha particle. No, alpha particle is having positive charge or negative charge. Alpha particles are having positive charge. So while performing the experiment, he observed that alpha particles were passing through the atoms without any scattering. But only one region, the alpha particles were getting reflected back or scattered back. And that was at the center of that atom. So Rutherford said that no, this entire region is not positively charged. He said that, Rutherford said that, what he said? He said that only there is a small region inside the atom where the positive charge is located. There is a small region inside the atom where the entire positive charge is located, and he called that region as what? Nucleus. He called that region as what? Nucleus. He said that a large amount of space in atom is empty. Only there is entire positive charge is located at one small region at the center of that atom, and that region he called is that what? Nucleus. So I hope you understood what is the defect of Thomson's model. Thomson's model said that the atom is nothing but entirely positive charge is uniformly distributed through the sphere. But what Rutherford was doing, he was performing the experiments using alpha particles. Alpha particles are having positive charge or negative charge. They are having positive charge. What will happen if there are two positive regions? If suppose this is positive region, if alpha particle is coming towards the positive region, what should happen? Positive, positive, attract or repel? Repel. It should go away. But what Rutherford has observed, he observed that the alpha particles are passing through the atom without getting deflected. Only the alpha particle which is passing through the center, it is getting reflected back. So he said that in atom, entire space is empty. Only at the center, entire positive charge is located, and that he called it as nucleus. And he further said that electron is accelerating around the nucleus. What is that? Electron is accelerating around the nucleus. Now, this was the defect of Rutherford model. I hope you understood this. So, what Rutherford said that? Rutherford said that in an atom, large amount of space is empty, and at the center of the atom, what is located? Positive, entire positive charge is located at the center of the atom. That is called as nucleus. And further, what he said that electron is accelerating around the nucleus. Now, this was the defect of Rutherford model. Let us discuss the defect of Rutherford model. Our actual FAQ answer for your annual examination starts from here. Defect of Rutherford model of atom. Defects of Rutherford model of atom. Now see here, carefully see here. There are two things you are supposed to understand here. If you are done with the two things, we can go with Bohr's model of atom. What Rutherford said, he said that entire positive charge is located at the center, and he called this one as what? Nucleus. He called this one as what? Nucleus. Further, what he said? He said that electron is accelerating around the nucleus. Now, the scientists have raised this question. What they said, as the electron is revolving around the nucleus, eventually it should emit radiation. As the electron is revolving around the nucleus, what should happen? It should emit the radiation. It should emit the radiation. Eventually, this electron's radius should decrease. As it is emitting the radiation, it should lose the energy, and eventually its radius should decrease, and it should fall inside the what? Nucleus. The electron should fall inside the nucleus, and atom should collapse. But this is happening? No. Now, when its explanation was asked by scientists to Rutherford, he was unable to explain. I hope you understood the defects. First, he was unable to explain the stability of electron. What the scientists have raised the question, as the electron is revolving around the nucleus, as the electron is accelerating around the nucleus, it should continuously emit the energy. While emitting the energy, it should lose the energy. Once it is losing the energy, its orbit should decrease. As its orbit is continuously decreasing, it should fall inside the nucleus, and the atom should collapse. But is this case happening? No, he was not able to explain this concept. Next thing, second defect. What is the first defect? As the electron is continuously losing the energy, it should fall inside the nucleus and it should collapse. But that's happening? No. What is the next defect of Rutherford model? As he said that electron is accelerating around the nucleus, as the electron is continuously emitting the radiation, the spectrum should be continuous. The spectrum should be continuous. Why the spectrum should be continuous? As the electron is accelerating around the nucleus, at every point it should emit the radiations of energy E is equals to h mu, and we should get a continuous spectrum. We should get a continuous spectrum. But what they have observed, they observed the spectrum to be discrete. The spectrum to be discrete. Actually, it should get a spectrum something like this, a band of spectrum we should get. We should get a band of spectrum. But what they have observed, They have observed a spectrum something like this. They have observed a spectrum something like this. Instead of band spectrum, they have observed a discrete spectrum. Discrete spectrum, or you can also call this one as line spectrum. So this was the another defect of Rutherford model of atom. Instead of observing discrete spectrum, actually according to its theory, we should get a continuous spectrum. But due to the experimentation, we came to know that the spectrum is how much? The spectrum is how? It is discrete manner, not continuous. So this was the another defect of Rutherford model of atom. I hope you understood this Rutherford defects of Rutherford model of atom. What is the first defect of Rutherford model of atom? As the electron is accelerating around the nucleus, it should continuously emit the energy. Once it is emitting the energy, it should lose the energy. After losing the energy, eventually the electron should fall inside the nucleus and the atom should collapse. Is that happening? No. And he was asked to explain, he was unable to give the explanation. Next defect is that as the electron is continuously emitting the energy, we should get a continuous spectrum. But what is the spectrum observed? The spectrum observed is what? Discrete, line spectrum. So these were the two defects of Rutherford model of atom. And these defects were corrected by whom? Bohr's model. Now, this is the important question for your examination. Bohr's model of atom. Bohr's model of atom. This is the important question for your annual examination. Bohr's model of atom. What he said that? He said that electron revolves around the nucleus. Electron revolves around the nucleus only in certain special orbits. Those orbits are called as stationary orbits in which they does not radiate any energy. What was the statement given by Rutherford? He said that, what he said? Here we are having nucleus and here the electrons are revolving. Let us assume that the energy here is E1 in this particular orbit, the energy here is E2 and the energy here is E3. Let us assume one electron is revolving here. In which orbit? Third orbit. Electron is revolving in the third orbit. So what was the first postulates of Bohr's model of atom? He said that this all things you have studied in 9th and 10th and even in first year chemistry also. That is the reason I'm just going on explaining. Here, what is the first postulate of Bohr's model? Electron revolves around the nucleus, in some special circular orbits known as what are the name of that orbits? Those orbits are called as stationary orbits. Stationary orbits. What is the specialty of this stationary orbit? It does not radiate. It does not radiate in these orbits. What does it mean? These are the special orbits called as the stationary orbit, in which whenever the electron is revolving around the nucleus, it does not radiate any energy. So what is the first postulate of Bohr's model of atom? Electron revolves around the nucleus in some special circular orbit. Remember this. Which orbit is talking? He is talking regarding circular orbit. Special circular orbit known as what? Stationary orbit, in which it does not radiate any energy. So it does not radiate in this orbit. So the defect of Rutherford model. What Rutherford model said that the electron is accelerating around the nucleus. So scientists have asked the question, if the electron is accelerating around the nucleus, it should continuously emit energy and eventually it should fall inside the nucleus and the atom should collapse. So in order to remove the difficulty, what Bohr said that he said that electrons are revolving only in certain special circular orbits. Those orbits are called as stationary orbits, in which electron does not radiate any energy. So this was the first postulate given by Bohr. What is the second postulate? He said that He said that, what he said, whenever an electron jumps from higher energy orbit to lower orbit, what will happen? While jumping, it will emit an energy of radiation h nu. It will emit an energy of radiation E is equals to how much? H nu. So what is the second one? Second postulate of Bohr's model of atom. When an electron jumps from any of the higher energy orbit to any lower orbit, it emits energy of radiation of energy how much? That is delta E is equals to H into nu. This was the second postulate given by whom? This was the second postulate given by Bohr's model. What was the first postulate? Electron is revolving around the nucleus only in certain special orbit called as stationary orbit. What is the specialty of that stationary orbit? The electron does not radiate any energy in that special orbit. What was the second postulate? Whenever an electron jumps from higher energy orbit to lower energy orbit, what will happen? It will emit some light of radiation E is equals to how much? H mu. And the third important postulate. Now the third postulate is important. Based on the third postulate, we are having one more FAQ, because when we have asked how you are getting the third postulate to Bohr, he said that I can't explain that. So its explanation was given by de Broglie. So we'll be studying one more important question from this. De Broglie's explanation of Bohr's quantization rule. That is nothing but the third postulate of Bohr's model of atom. So let me write down the third postulate here. Let me write down the third postulate here. What is the third postulate? The angular momentum of revolving electron is equal to the integral multiple of h by 2 pi, or you can also say the third statement as what? Angular momentum of revolving electron is quantized. You can say either you can write this statement or you can write this statement. What is this statement? The angular momentum of revolving electron is equals to what? Integral multiple of h by 2 pi. Otherwise, you can also write on this statement. What is the statement? Angular momentum of revolving electron is quantized. So what will be the equation here? Here we will be getting L is equals to integral multiple n into h divided by 2 pi. What does L represent? L represents what? Angular momentum. So it is given as MVR is equals to NH divided by 2 pi. MVR is equals to what? NH divided by 2 pi. So these are the important postulates of Bohr's model of atom. In the examination, he may ask you to write down the postulates of Bohr's model of atom. What you are supposed to do? You are supposed to draw this diagram. You are supposed to write down the first postulate. What is the first postulate? Electron revolves around the nucleus only in certain special orbit called as stationary orbit. What is the specialty of that stationary orbit? Electron does not radiate any energy while revolving around those circular orbit. What is the next important point? Whenever an electron jumps from higher energy orbit to lower energy orbit, it will emit some radiation of energy delta E is equals to how much? H into nu. And what is the third important postulate for Bohr's model of atom? The angular momentum of revolving electron is quantized, or you can say the angular momentum of revolving electron is equals to NH by 2 pi. So from here, we'll be getting one more question. What is that question mean? Bohr was asked to explain this statement, explain regarding this statement, but Bohr was unable to do. He was asked to derive this formula, but Bohr was unable to do. Then who has explained this concept? De Broglie has explained this concept. Let us move on to that question itself. What is the question? De Broglie's explanation of Bohr's quantization rule. What is the question? De Broglie's explanation of Bohr's quantization rule. Let us move on to the next question. Important question. This question was asked in your main examination, recent annual examination. de Broglie's explanation of Bohr's quantization rule. Bohr's quantization rule. Bohr's quantization rule. Now carefully see here. Carefully see here. See here, what Bohr said? He said that this is the nucleus. Around the nucleus, electron is revolving. And Bohr said that, what Bohr said? Bohr said that Bohr said that what he said? Angular momentum of revolving electron, that is nothing but L is equals to mvr is equals to nh by 2 pi. That is, angular momentum of revolving electron is quantized. This was the statement given by Bohr. What is it? The angular momentum of revolving electron is quantized. That is nothing but the angular momentum of revolving electron is equals to what? Integral multiple of h by 2 pi. When he was asked to explain this, he was unable to give the explanation, but its explanation was given by whom? Its explanation was given by de Broglie. So what does de Broglie said? According to de Broglie, according to de Broglie, the wavelength associated with the revolving electron is given as, here, this is the statement given by whom? De Broglie. He said that the wavelength associated with the revolving electron, suppose electron is moving, he said that along with that electron, there will be a wave which will also move, that is called as matter wave. And that wave is known as de Broglie wave. And he said that the wavelength associated with the revolving electron is given as what? Lambda is equals to h divided by m into v, where lambda is called as what? This is called as de Broglie's wavelength. De Broglie's wavelength. So see here. Now de Broglie is giving the explanation for Bohr's quantization rule. So according to de Broglie, what he said, he will be discussing the concept of what? Dual nature of matter and radiation. So whenever an electron is revolving around the nucleus, de Broglie said that along with that electron, a wave is associated. And what is the name of that wave? That wave is called as matter wave. And the wavelength of that wave is given as what? Lambda is equals to h by mv. This lambda is called as de Broglie wavelength. Now see here. The total path covered by the electron can be written as what? It is covering a circumference. Circle, na? It is circumference of circle is given as what? Total length covered by that electron. 2 pi r is equals to, how many wavelengths can be there? There can be 1, 2, 3, 4, 5, 6 constructive wavelengths. Path difference for constructive interference, how much? Delta x is equals to n lambda. So here total path is how much? 2 pi r. So 2 pi r is equals to, he has written n lambda. So n lambda can be 1 lambda, 2 lambda, 3 lambda, 4 lambda, 5 lambda, but it can't be 1.5 lambda, it can't be 0.5 lambda, it can't be 2.5 lambda, it should be integral multiple of lambda. So see here, from here I can write 2 pi r is equals to n into, what is the value of lambda we got according to de Broglie? Lambda is equals to h by mv. Lambda is equals to h by mv. If I take mv here and bring 2 pi here, what this will become? This will become mvr is equals to nh divided by 2 pi. That is nothing but L is equals to what? nh divided by 2 pi. This was the explanation given by de Broglie based on wave dual nature of matter and radiation. So hence proof. So what will be the question in the examination? You'll be getting a question that how de Broglie explained the Bohr's quantization rule. So first, what you are supposed to do, first of all, you are supposed to write down the Bohr's postulate quantization rule. What is Bohr's quantization rule? The angular momentum of revolving electron is quantized. Then you are supposed to write down this formula. What is that formula? L is equals to MVR is equals to NH by 2 pi. Now, what did de Broglie said? According to de Broglie, whenever an electron is revolving around the nucleus, along with that electron, what is associated? A wave is associated. What is the name of that wave? That is called as matter wave. And the wavelength of the wave is given as what? Lambda is equals to h by mv, where lambda is called as what? Lambda is called as de Broglie wavelength. Now, the electron is starting from this particular position. Again, it is reaching this particular position. It has covered an entire circle. What will be the circumference of a circle? What will be the total distance covered by the electron? It is 2 pi r, and that should be equals to what? The wavelength. So I have written n lambda. It can be 1 lambda, 2 lambda, 3 lambda. So what is the value of lambda here? Lambda is equals to h by mv. If I substitute this value and if I take this mv to the left side and bring 2 pi to the right side, what this will become? This will become MVR is equals to NH by 2 pi, which is the Bohr's quantization rule. So in this manner, de Broglie was able to explain the Bohr's quantization rule. I hope you understood this answer. This question was asked in annual examination in just 2 months before. Very important question. So what are the things that we have discussed? Initially, we have started with Thomson's model of atom. Further, after Thomson's model of atom, we came to know about the Rutherford model of atom. And further, what we have discussed the defects of the Rutherford model of atom. How many defects there? There were 2 defects. Then we have discussed regarding the postulates of Bohr's model of atom. And when Bohr was asked to explain the third postulate, he was not able to give any explanation. And this third postulate, postulate of quantization of rule, was explained by whom? It was explained by de Broglie. This was explained by whom? It was explained by de Broglie. I hope you understood the concept still here. Let us move on to the next important SAQ from this chapter. What is the next important SAQ from this chapter? Limitations of Bohr's model of atom. Another important question for your annual examination. Limitations of Bohr's model of atom. Limitations of what? Bohr's model of atom. Limitation of Bohr's model of atom. So what are the limitations of Bohr's model of atom? The first limitation is it is applicable only for hydrogen-like atom. Hydrogen-like atom. So 1 electron system. Next one. So next important point is, he said that electron revolves only in certain circular orbits, but there are elliptical orbits are also possible. When he was asked why you haven't considered the elliptical orbits, means he was unable to explain that concept. So he was unable to explain why only circular orbits, when elliptical orbits are also possible. Elliptical orbits are also possible. He was unable to explain. So what was the first thing he was unable to explain? This model is applicable only for which atom? Only hydrogen-like atom, that is single electron system. And further, what he was unable to explain? He was unable to explain why only certain circular orbits are permitted when elliptical orbits are also possible. And the next important limitation is that he was unable to explain. Third one, he was unable to explain the phenomena of, he was unable to explain the phenomena of Riemann effect, and Stark effect. Stark effect. I hope you know what is the Riemann effect and Stark effect. You might have studied in your chemistry classes. Riemann effect is related with magnetic field, and here Stark effect is related with electric field. What is the first limitation of Bohr's model of atom? It is applicable only for hydrogen-like atoms. And what is the next limitation? He was unable to explain only why we should only consider circular orbit when elliptical orbits are also possible. And what is the third limitation of Bohr's model of atom? He was unable to explain the phenomena of Riemann effect and Stark effect. So let us see what is the fourth limitation. He could not explain, he could not explain fine structure of hydrogen atom. He was unable to explain the fine structure of hydrogen atom. This is the fourth limitation. Fine structure of spectral lines. Fine structure of spectral lines of hydrogen atom. So next, if you want, you can write only 4. If you want, you can write one more extra thing. He was unable to explain the wave nature of electron. The wave nature of what? Electron. So these are the few limitations of Bohr's model of atom. What are those limitations? It is applicable only for hydrogen-like atom. What was the second limitation of Bohr's model of atom? He was unable to explain why only certain circular orbits are allowed when elliptical orbits are also possible. What is the third limitation? He was unable to explain the phenomena of what? Stark effect and Riemann effect. What is the fourth one? He could not explain the fine structure of spectral series. We know what is the spectral series of hydrogen atom? Lehman series, Balmer series, Paschen series, Brackett series, and Pfund series. He was unable to explain the fine structure of spectral lines of hydrogen atom. And what is the last limitation that we have discussed? Here, he was unable to explain the wave nature of electron. He was unable to explain what? Wave nature of electron. I hope you all are writing these things, because these are the things which are necessary to write in the examination. For each point, you will be getting 1 mark. So for writing 4 points, you will be getting 4 marks. Now let us move on to some mathematical part of Bohr's model of hydrogen atom. In this mathematical part, we are going to obtain an expression for radius of nth Bohr orbit, energy of nth Bohr orbit. So carefully see this mathematical part. See here. I'm writing here radius and energy of electron in hydrogen atom. Here in a case of hydrogen atom, what is the atomic number Z? We'll be writing Z is equals to 1. So everyone carefully see here, mathematical derivation is there, very easy derivation. See here. Let us consider an atom. We know that according to Bohr's model, we are having a nucleus here. Electron is revolving around this nucleus with some velocity v. This is the radius r. Now, what are the forces acting here? We know that there are 2 forces acting here. One, the centripetal force of that electron is responsible due to electrostatic force between this nucleus and this electron. So I can write here, first one. Carefully see here, very easy derivation. What are the forces acting here? centripetal force is equals to electrostatic force. Centripetal force is equals to electrostatic force. What is the formula for centripetal force? We know that the formula for centripetal force is given as mv square by r is equals to what is the force between two electrostatic charges, two charges. We know that according to Coulomb's law, F is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. What is their charge Q1? It is ZE. What is their charge Q2? E. So what this will become? This will become ZE square divided by 4 pi epsilon naught into R square. ZE square divided by 4 pi epsilon naught into R square. So here R, here square will get cancelled. Finally, we'll be left with what? mv square is equals to ZE square divided by 4 pi epsilon naught R. See here, if you are practicing only, you will be getting this equation. Just by looking at this equation, you will feel that yes, this is very easy. But while writing the examination, you won't remember anything. Just try to practice this. Now see here. Everyone carefully see here. Now we know that according to Bohr's quantization rule. What is the Bohr's quantization rule? We know that m VR is equals to what? NH divided by 2 pi. From here I can write V is equals to what? NH divided by 2 pi m into R. V is equals to what? NH divided by 2 pi m into R. Now see here. Now we are going to determine the first expression. What is the first expression? Radius. We are going to obtain expression for what? Radius. Now carefully see here. What is the equation we got? We got one equation. mv square is equals to ZE square divided by 4 pi epsilon naught into R. Now what is the value of V we got? Let us substitute the value of V here. If I substitute this value of V here, what this equation will become? This equation will become m into, what is the value of V? NH divided by 2 pi mr into whole square ZE square divided by 4 pi epsilon naught into R. If I square this, what this will become? This will become m into n square h square divided by 2 square will become 4 pi square m square into R square. That is equals to what? ZE square divided by 4 pi epsilon naught into what? R. 4 pi epsilon naught into R. Now see here, what are the things that are getting cancelled? This m and square, this 4 and this 4, this pi and this square, this R and this square is getting cancelled. Now what I am taking? I am taking this R to the right hand side. I am bringing all the left hand side, right hand side region towards the left hand side. What it will become? See here. I'll be getting, I am taking this R, denominator R to here. So this will become R into ZE square divided by epsilon naught. R into ZE square divided by epsilon naught. Here we are left with what? N square h square divided by, here one pi is left, here m is left. So what is our final equation? From here I can write, my final equation as what? What you are supposed to determine? You are supposed to determine the radius. So R is here. So our radius equation will become R is equals to epsilon naught will go to left hand side numerator. So this will become what? N square h square epsilon naught divided by this ZE square will go to downward region. So this will become pi z m e square. You are supposed to remember this formula. What is the radius of nth Bohr orbit? What is the radius of nth Bohr orbit means? You should remember the formula n square h square epsilon naught by pi z m e square. Nth orbit, sorry. This is what? Radius of nth orbit. But we are calculating this for what? Hydrogen atom. For hydrogen atom, what is the value of Z? For hydrogen atom, the value of Z is how much? Z is equals to 1. Z is equals to what? Z is equals to 1. If I substitute the value of Z is equals to 1, I'll be getting radius of nth orbit as n square h square epsilon naught by Z m e, sorry, pi m E square, because the value of Z is 1. I hope you understood this expression. See here what I did. I said that an electron is revolving around the nucleus. You are supposed to determine the radius and energy of this revolving electron, in which case, in case of hydrogen atom. So what is the two forces acting here? One force is acting towards the center, that is called as centripetal force, and the other force is acting between the nucleus and electron. What is the type of force? That is called as electrostatic force. So we know that this centripetal force is equals to electrostatic force. What is the formula for centripetal force? mv square divided by r. And what is the formula for electrostatic force? We know that according to Coulomb's law, electrostatic force formula is given as F is equals to 1 by 4 pi epsilon naught into Q1 Q2 by r square. What are the charges here? Q1 is ZE and Q2 charge is E. So ZE into E will become what? ZE square divided by 4 pi epsilon naught r square. So from here, r and square will get cancelled. We'll be left with what? We'll be left with one equation. What is that equation? mv square is equals to ZE square by 4 pi epsilon naught r. Now from both quantization rule, we know that the angular momentum of revolving electron is equals to what? Integral multiple of h by 2 pi. So from here, I have substituted the value of v in this equation. What is that equation? mv square is equals to ZE square by 4 pi epsilon naught r. After solving this, what is the formula for the radius of nth Bohr orbit you are getting? N square h square epsilon naught by pi z ma square. We are discussing the case of hydrogen atom. For hydrogen atom, what is the value of Z? Z is equals to 1. So I hope you understood this. Let us move on to the next expression. What is the next expression? Next expression is regarding the total energy. What is the next expression? Next expression is regarding the total energy. So see here. So we got one equation. What was that equation? mv square is equals to ZE square divided by 4 pi epsilon naught into r. This was the one equation we got initially. What was the second expression we got? What was the second expression? The second expression was V is equals to NH divided by 2 pi mr. This was the second expression we are supposed to remember for obtaining the expression for energy. Now carefully see here. Now we are, first of all, we are going to derive the expression for kinetic energy. Kinetic energy. I hope everyone know what is the formula for kinetic energy. Basic small answer. A small student can also answer this one. What is the formula for kinetic energy? Kinetic energy K is equals to how much? 1 by 2 mv square. What is the value of mv square? Let us substitute the value of mv square. This will become 1 by 2 into value of mv square is how much? ZE square divided by 4 pi epsilon naught into what? Into r. If I substitute the value of mv square, what it will become? 4 pi epsilon naught into r. So what is the final expression? So kinetic energy K is equals to ZE square divided by 4 to the how much? 8 pi epsilon naught r. Let us substitute the value of r. What was the value of r we got? Radius of nth Bohr orbit r is equals to n square h square epsilon naught divided by pi z m e square. Pi z m e square. This was the expression we got for radius. This was the expression we got for what? Radius. So if I substitute that value, what it will become? Everyone see here. So kinetic energy is equals to ZE square divided by 8 pi epsilon naught. Now let us substitute the value of r here. What is the value of r? N square h square epsilon naught divided by, what is that? Pi z m e square. Pi z m e square. What are the things that are getting cancelled here? See here. This pi and this pi is getting cancelled. So finally, this z will go to numerator, this m will go to numerator, and this e square will also go to numerator. So what will be the final expression for kinetic energy we will be getting? The final expression for kinetic energy we will be getting is kinetic energy is equals to z into z will become z square. What is left? M. E square into e square will become e power 4 divided by 8 into epsilon naught will become epsilon naught square. 8 epsilon naught square n square h square. So this is the expression for kinetic energy. This is the expression for what? This is the expression for kinetic energy. Similarly, we can obtain the expression for potential energy. Potential energy. So the expression for potential energy, I'm writing directly. The expression for potential energy is given as PE is equals to minus ZD square divided by 4 pi epsilon naught R. What is the expression for potential energy? Minus ZD square divided by 4 pi epsilon naught R. If I substitute the value of R here also, let us substitute the value of R here. What this will become? Potential energy is equals to minus ZD square divided by 4 pi epsilon naught. What is the value of R? The value of R is n square h square epsilon naught divided by pi zm e square. Pi zm e square. So what is happening here? Here this pi and this pi is getting cancelled. Again, z into z will become z square. M is m. E square into e square will become e power 4. So what is the final expression for potential energy I will be getting? Potential energy is equals to minus z into z, z square, m, e square into e square, it will become e power 4 divided by epsilon naught into epsilon naught square into n square into h square. So this is the final expression for what? This is the final expression for which energy? Potential energy. Now the conclusion, last step. Total energy. What is the third one? Total energy of an electron revolving around the nucleus in case of hydrogen atom. What is the formula for total energy? Total energy is given as kinetic energy plus potential energy. So what is the expression for kinetic energy we got? What is the expression for kinetic energy we got? Z square m e power 4 divided by 8 epsilon naught square n square h square. And what is the expression for potential energy we got? Minus z square m e power 4 z square m e power 4 divided by 4 epsilon naught square n square h square. If you solve this, what this equation will become? This will become minus z square m e power 4 divided by 8 epsilon naught square n square h square. See here what I can take. I take LCM as 8. Here we'll be getting 2. 1 minus 2 will become minus 1. So what is the final expression for total energy? Energy is given as minus z square m e power 4 divided by 8 epsilon naught square n square h square. So this is the final expression for total energy of an electron. For hydrogen atom, what is the value of Z? For hydrogen atom, Z is equals to how much? Z is equals to 1. So I can write total energy of hydrogen atom as H is equals to minus m e power 4 divided by 8 epsilon naught square n square h square. What does this negative sign signify? Negative sign tells that electron is bound to the nucleus. So let us finish today's class here itself. So what we have discussed today, we have started with one small concept of electric potential and capacitance, which I have left. Next, we have started the atoms chapter. We have discussed regarding Thomson's model of atom. What was Thomson's model of atom? He assumed that the atom is nothing but a positively charged sphere in which electrons are embedded, but it had some contradictions. As Rutherford was performing experiment with alpha particles, all the alpha particles were passing through the atom. Only the alpha particle which was passing through the center, it was getting reflected. So Rutherford said that no, the entire space is not filled with the positive charge. The positively charge is concentrated only at the center of the atom, and the entire large amount of space inside an atom is empty. Further, what is it that electron accelerates around the nucleus? So scientists have asked the question to Rutherford, whenever the electron is accelerating around the nucleus, it should continuously emit the radiation. Eventually, its radius should decrease and it should lose the energy and it should fall inside the nucleus and the atom should collapse. Is that happening? No, it is not happening. So Rutherford was unable to explain that concept. Further, as the electron is continuously emitting the radiation, we should get a continuous energy spectrum. But the spectrum we were getting was discrete spectrum. So this two things were the defects of Rutherford model of atom. Later on, we came to know about the Bohr model of atom. Bohr said that no, the electrons are revolving around one special orbit. Those special orbits are called as what? Stationary orbits. What is the specialty of that stationary orbit? The electrons never radiate energy in those stationary orbits. What was the second postulate given by Bohr's model of atom? Whenever an electron jumps from higher energy orbit to lower energy orbit, it will emit energy, radiations of some energy, delta E is equals to h nu. And what was the third famous postulate of Bohr's model of atom? Whenever an angular momentum of revolving electron is equals to what? NH divided by 2 pi. That is, angular momentum of revolving electron is quantized. Whenever the scientists have asked regarding the explanation of this third postulate, Bohr was unable to explain that quantization rule. So who has given the explanation for that quantization rule? De Broglie has given the explanation for that quantization rule. He said that whenever an electron is revolving around the nucleus, along with that electron, a wave is associated. He named that wave as matter wave. And the wavelength of that wave was given as de Broglie wavelength, and it is lambda is equals to h by mb. And further, he was able to prove that that quantization rule. What was the quantization rule? mbr is equals to nh by 2 pi. Next, we have studied regarding the limitations of Bohr's model. Bohr's model is applicable only for hydrogen-like atom. He was unable to explain the Zeeman and Stark effect. He was unable to explain only why we should only consider the circular orbit, why not the elliptical orbit. Further, what was the one more thing? He was unable to explain the fine structure spectral series of hydrogen atom. Next, what we have discussed regarding the expressions for radius and total energy of an electron revolving around the nucleus in case of which hydrogen atom. So let us finish today's class here itself. Tomorrow we are going to discuss one more important question from atom, that is spectral series of hydrogen atom. Once we are done with that, we will move on to the other chapter. Okay, I hope you understood this today's class. We'll meet tomorrow. Thank you.